Today we're going to look at using the inverse of trigonometric functions. This is section 9.6. We will break it into two parts. So this is part A. So let's talk about what these inverse of these trigonometric functions are. First, our bell ringer. This will relate to what we're doing today. So write the sine of f equation. So if we look at our triangle here, here's angle F. So let's go ahead and label our sides relative to F here. This would be the opposite across from it. Here's your hypotenuse, and this would be your adjacent. For the sine of F, we want to do, remember our little saying there. Sine is so it's sine equals opposite over hypotenuse. So we'll write sine of f is equal to opposite, which is the 5, over hypotenuse, which is 13. And we're done. Let's write the cosine now for it. Cos, C-A-H, cosine equals adjacent over hypotenuse. So we'll go cosine f equals the adjacent side here is 12 over the hypotenuse again, which is 13. And lastly, the tangent function, oops, don't write tangent, but write TOA. TOA, tangent equals opposite over adjacent. Let's write that. Tan F. And we look over at our diagram. We want opposite, so that's 5 over adjacent, that's 12. So opposite over adjacent. It asks us to classify angle F here. Well, angle F has to be a acute angle. It's got to be less than 90 degrees. We already have a 90-degree angle in there. I think that is in the wrong order here. It's all right. We'll work it from here. So let's take a look at the 30, 60, 90 triangle. If you recall, the ratio for the 30, 60, 90 across from the 30 is x, hypotenuse 2x, and the longest side, or the longest leg, I should say, is x root 3. If I asked you at this point to find the sine of 30, you could do, remember sine is so, and relative to 30, this is the opposite, the hypotenuse, and the adjacent. So if you were asked to find the sine of 30, it'd be opposite over hypotenuse, or 1x over 2x. And so the sine of 30 degrees is 1x over 2x, or just 1 over 2, or 0.5. And so every 30, 60, 90 triangle, their opposite over their hypotenuse is always 0.5 or a half. And if you try this on your calculator, and I'm going to show you on mine, so I'm going to type in 30. The calculator's in degrees, if you'll notice. It's right up there. So I've typed in 30. I'm going to press the sine button. And it gave me the wrong answer. Let's try that again. 30 and sine. And it is 0.5, just like the ratio, or the ratio done with the 30, 60, 90 triangle tells us. So the point is, every time you type in sine 30, it is calculating for whatever that angle is. Maybe that angle's steeper than 30. Maybe it's 35 degrees. When you typed in sine 35, it's going to give you a different ratio, because in the 35-degree triangle, this leg is longer all of a sudden than this base side was, and the hypotenuse has also gotten longer as well. So it changes, obviously, the ratios. So that's what our sine does. The sine function takes the 30-degree angle and it pairs it up with that ratio. And our calculators have all those things memorized. So this is, in summary, what our trig functions do. They take an angle, the sine function gets applied, and it tells us what the opposite over hypotenuse ratio is. Now, it usually gives it, in fact, it always gives it as a decimal value. Just like we got 0.5, well, when we do it by hand, we get it as 1 over 2. So all these decimals are the fractions we would have gotten. So I ran a quick little table here for a bunch of different angles, and I took the sine of the angles. And so this is what our calculator essentially does. For each angle, it gives you the matching ratio. And I've got a statement down here. Wouldn't it be awesome if we had something that went in reverse? I knew the ratio of the opposite, the hypotenuse, and then it would tell me the angle. So the sine function takes the angle and maps it over to a ratio, and we're looking for something that would take a ratio and map it back to the angle that it would come from. So we're trying to find this other function. Well, it turns out there is one, and they're very clever about it. Note this notation here. Sine with a little -1 above it. Okay, this always means inverse of the function below it. In fact, if you look over here at the calculator, I can't point with my highlighter, but right below sine, you see sine to the -1, cosine, that -1. Now, the way you read this is the inverse of sine. And what the inverse of sine does is it takes the ratio, this answer here, it takes that and maps it back to the acute angle that it came from. So it just undoes what the sine function does. You can try it on your calculator. We just found out that the sine of 30 degrees was a half. Now what happens if we do the inverse sine of a half? I'm going to clear my calculator here, type in my 0.5, and this time I'm hitting the sine with the -1 above it, inverse sine. And you can see it gives me 30 back. I'm in degrees, you can see up here, and so it's 30 degrees. That little 1 sitting off at the end, that's just computer error as they carry out these calculations. So today we're just learning to work with this inverse sine to take the ratio, the decimal, and convert it back to the angle from where it came. Now, you saw it on the calculator over there. We have inverse functions for all of our tangents. Okay, so using inverse sine will undo the sine function. Using the inverse of cosine will undo a cosine function, and inverse of tangent will undo the tangent function. But regardless, whichever one you use, it's going to return back the angle that it came from. Go ahead and let's try and answer these questions here. Now, when they say tan A equals 3.5, and you're trying to solve for A, what this means to do is, see, they told you what the ratio is. In this triangle, for whatever angle A is, the ratio, the tangent ratio comes out to 3.5. So to undo it, we want to take the inverse tangent of 3.5, and that will map it back to the angle. So on my calculator, I'm going to clear it, and I'm just going to type in 3.5, and I will hit the inverse tangent button, and it tells me the angle, and that's the angles to measure. Measure of angle A must be 74.1, and that's in degrees. Now, mathematically, or algebraically, I should say more appropriately, what we're doing in this problem here is we're trying to undo this tan function. So mathematically, you show this process by the following. You take each side and raise it to the inverse tangent. And I'm going to write it down below because that's going to get too crowded there. You have inverse tangent of tan A equals inverse tangent of 3.5. And what happens on the left-hand side, tangent would do something to A and inverse tangent would undo it. So these two functions, one does something, the tangent, the inverse undoes it. So these two basically cancel out. And so mathematically, your left side just becomes A. And on the right side, we've got that tangent inverse of 3.5, which is exactly what we did to find that angle. So in the second example here, sine A equals 0.55. In your head, mentally, what you're doing is you're inversing sine the left side, and the signs cancel, and then you inverse sine the right side, because you have to do the same thing to both sides. And so what you end up with is A equals inverse sine of 0.55. And so grab your calculator at that point, put in your 0.55, and hit the inverse sign to undo it, and it tells us the measure of angle A in this case must be about 33.4 degrees. And lastly, we've got the cosine of A, so we're going to inverse cosine both sides. And we grab our calculator. 0.45 inverse cosine. And I'm getting 63.3 degrees. And that's it, applying the inverse to a ratio to find the angle. That's pretty straightforward. Now we can also use these inverse signs to actually solve for angles if we know two sides, and you should understand now how this is possible. If we can figure out what the ratio is, because they tell us two sides, then we can use the inverse trig to figure out what that angle was in the triangle. So the setup is very similar to yesterday, except yesterday we wanted to start with an angle that we knew. Today we're going to be looking for the angle. So start by choosing an angle that you want to solve for. Label using that angle, the angle that you're trying to find, label your opposite, adjacent, and hypotenuse. And then lastly, you're going to choose which tangent or which trig function you're going to use. And you're going to do that by choosing a trig function with your chosen angle with the ratio of sides that we know in the triangle. And you'll see that as we go through. Once we get it set up, everybody, it's the same thing as we've always done. Substitute in and then solve. Okay, and solving again, we'll have to use our inverse function to solve these things. So let's take a look at the triangle here, and let's solve this for angle A. So angle A is down here, so let's go ahead, put a little mark down here, and let's label our opposite, our hypotenuse, and our adjacent sides. And in this case, we know the opposite side and we know the adjacent side. And so then we think about our trig functions. We've got our SOHCAHTOA relative to A, we know the opposite, we know the adjacent, and that is clearly the tangent function. So we would write our setup as the tangent of A is equal to CB, that's the opposite side, over the adjacent AB. So tangent A equals 12 over 6, or tangent A equals 2. And so 8 equals inverse tan of 2. And then we'll just grab our calculator. And we'll go 2 and inverse tangent. And it tells us that angle A I should put measure angle A equals 63.4 degrees. So we know what A is. Now, at this point, everybody, we should be able to tell ourselves what C is. So if I wanted to find the measure of angle C, we use that triangle sum theorem. It says, hey, all triangles have 180 degrees in them. I'm going to round this 63 so I don't have to do any decimal math. Let's round him off to just 63 degrees. I'm going to subtract off the 90 here. I'm going to subtract off the 63 here, and that gives me 27 degrees. So I know now angle C up here is 27 degrees. But we want to be able to solve for C by using our trig, because that's what we're practicing. But now we can see if our trig is working if we actually get that 27 degrees. Now, to find C up here, we're going to have to reset our opposites and our adjacents here. So I'm going to erase a little bit and erase a little bit. And now the opposite side over here and the adjacent side is over there. Let's choose our trig function. From 27, I don't know the hypotenuse, but I do know opposite, I do know adjacent. Opposite and adjacent go with tangent, so my setup's going to be the tangent of angle C is equal to the opposite AB over the adjacent CB. We do our substitution. Tangent of C equals 6 over 12. So tangent C equals 0.5, and C equals the inverse, therefore, of 0.5. And so now if we grab our calculators, type in that 0.5 and take the inverse tangent of it, you'll see we get C equals 26.6, which would round to 27 degrees. So just like we predicted. So obviously we could have done that 27 a different way, but the entire point is we didn't know any angles to begin with. And we can actually use trig now to find that unknown angle. Let's look at another example here. All right. Let's see, solve for angle A. That should not be angle A. Well, that must be angle G, and this must be angle F, our two acute angles. So let's go ahead and mark off G. So this is our opposite side. Right next to it is our hypotenuse, and this is our adjacent side. And we've got, we're trying to find angle G, so we have opposite and we have adjacent. So if we know opposite and adjacent, we could use tangent. But they've also given us the hypotenuse here. So let's use a different trig function this time. This is opposite, this is hypotenuse. I'm going to use the sine function. So I'll go sine of angle G equals opposite, which is EF, over adjacent, which is EG. So sine of G equals 72. Oh, shoot. I'm doing sine. Sorry. Hypotenuse is GF. So sine G equals 72 over 97, and therefore G equals inverse sine of 72 over 97. So on my calculator, I'm going to type in 72 divided by 97. I'll get an answer for that. And then I'll just do inverse sine of it. Note I haven't written anything down. And so G is equal to 47, let's call it 48 degrees. So we know G now. Let's go ahead and find F. Now when we find F, since we're switching angles, we're going to have to redefine our opposite and our adjacent, although it's really not going to matter in this problem. Oh yeah, well, sorry, I was thinking I had an isosceles right triangle. So now relative to the 72, opposite is over here, and adjacent would be right there. And again, we got to pick our trig function. We could use tangent because we know opposite and adjacent. We could use sine, opposite over hypotenuse, or we could use cosine, adjacent over hypotenuse. If I were you, I would pick a favorite trig function, one that you can always go to. In general, I always use sine just because that is the first trig function. But I'm going to go ahead and use cosine for this one, just so you can see us using the cosine function to solve. So cosine of angle F. And if I'm using cosine, that's ca. So adjacent is 72, which is EF, over hypotenuse, which is GF. So F equals the inverse cosine of EF, which is 72 over, oh, I'm doing sine. No, I'm doing cosine. Sorry. Which is adjacent 72, the EF, over the hypotenuse, which is 97. So grab your calculator, and we'll go 72 divided by 97. And then we'll hit the inverse cosine button, and it tells us measure angle F is 42 degrees. Let's see if our triangle now adds up to 180. We got 90 at the top of our triangle. One of the angles is 48, the other is 42 that we found. That adds up to 90, and 90 and 90 is 180. Okay, so that's just a check to verify that we do indeed have a triangle with 180 degrees in it. Now you don't have to check that. That's just for our purposes of learning it. That's probably good enough. Here's your assignment. Pretty straightforward. At the very beginning, remember, this is what we practiced straight up at the start of the lesson, where you just have to inverse sine both sides, inverse cosine, inverse tangent. Here's where you set it up. Again, use trig to solve for both angle A and B, and then it's, you can go back and just check mentally to see if it does add up to 180 to kind of make sure